Hi, my roll number is 21951A1250 and myself I am Y Nitish Kumar. My topic is solar cell construction. A solar cell or photovoltaic cell is an electronic device that converts the energy of light directly into electricity by the photovoltaic effect, which is a physical and chemical phenomenon. It is a form of photoelectric cell defined as a device whose electrical characteristics such as current, voltage, or resistance vary when exposed to light. Individual solar cell devices are often the electrical building blocks of photovoltaic modules known colloquially as solar panels. The common single junction silicon solar cell can provide a maximum open circuit voltage of approximately 0.5 volts to 0.6 volts. Solar cells are described as being photovoltaic irrespective of whether the source is sunlight or an artificial light. In addition to producing energy, they can be used as a photodetector. For example, infrared detectors detecting light or other electromagnetic radiation near the variable range or measuring light intensity. The operation of a photovoltaic cell requires three basic attributes: the absorption of light generating excisions, unbound electron hole price or plasmons, the separation of charge carriers of opposite types, the separate extraction of those carriers to an external circuit. In construct, a solar thermal collector supplies heat by absorbing sunlight for the purpose of either direct heating or indirect electrical power generation from heat. A photoelectrolytic cell, on the other hand, refers either to a type of photovoltaic cell by Edmond Becquerel and modern dye synthesis or to a device that splits water directly into hydrogen and oxygen using only solar illuminations. Photovoltaic cells and solar collectors are the two means of producing solar power. Cells, modules, panels, and systems. Multiple solar cells is in an integrated group, all oriented in one plane, constitute a solar photovoltaic panel or module. Photovoltaic modules often have a sheet of glass on the some facing side, allowing light to pass while protecting the semiconductor wafers. Solar cells are usually connected in series, creating additive voltage. Connecting cells in parallel leads a higher current. However, problems in parallel cells such as shadow effects can shut down the weaker parallel string, causing substantial power loss and possible damage because of the reverse bias applied to the shadowed cells by their illuminated partners. All the modules can be interconnected to create an array with the desired peak DC voltage and loading current capacity, which can be done with or without using independent MPPTs or specific to each module. With or without module level power electronic units such as micro inverters or DC-DC optimizers, shunt diodes can reduce shadowing power loss in arrays with series or parallel connected cells. History: the photovoltaic effect was experimentally demonstrated first by French physicist Edmond Becquerel in 1839. At age 19, he built the world's first world's first photovoltaic cell in his father's laboratory. Willoughby Smith first described the effect of light on selenium during the passage of an electrical current in a 28th February 1873 issue of Nature. In 1883, Carlos Fritz built the first solid-state photovoltaic cell by coating the semiconductor selenium with a thin layer of gold to form the junctions. Space applications: solar cells were first used in prominent application when they were proposed and flown on the Vanguard satellite in 1958 as an alternative power source to the primary battery power source. By adding cells to the outside of the body, the mission time could be extended with no major changes to the spacecraft or its power systems. In 1959, the United States launched Explorer, featuring large wing-shaped solar arrays, which became a common feature in satellites. These array considered of 9600 Harman solar cells. Improved manufacturing methods. Improvements were gradual over the 1960s. This was also the reason that costs remaining high because space users were willing to pay for the best possible cells, leaving no reason to invest in lower cost, less efficient solutions. The price was determined largely by the semiconductor industry. Their move to integrated circuits in the 1960s led to the availability of larger ball site lower relative prices as their price fell. The price of the resulting cells did as well. These effects lowered 1971 cell cost to some $100 per watt. Research and industrial production flowing in 1973 all crisis all companies used their higher profits to start solar farms and were off for decades. The largest producers, Exxon, Arco, Shell, Maco, and Mobil, all had major solar divisions during the 1970s and 1980s. Technology companies also participated, including General Electric, Motorola, IBM, Tyco, and RCA. Research into solar power for terrestrial applications became prominent with U.S. National Science Foundation's Advanced Solar Energy Research and Development Division within the research supplied to National Leads Program, which ran from 1969 to 1977 and funded research on developing solar power for ground electrical power systems. 1973 conference, the Cherry Hill Conference, set forth the technology goals required to achieve his goal and outlined an ambitious project for achieving them, kicking off an applied research program that would be ongoing for several decades. The program was eventually taken over by the Energy Research and Development Administration, which was later merged into the U.S. Department of Energy. The solar cell works in several steps. Photons in sunlight hit the solar panel and are absorbed by semiconducting materials such as doped silicon. An array of solar cells converts solar energy into usable amount of direct current electricity. An inverter can convert the power to alternating current efficiency. Solar cell efficiency may be broken down into reflectance efficiency, thermodynamic efficiency, charge carrier separation efficiency, and conductive efficiency. The overall efficiency is the product of these individual matrices. The power conversion efficiency of a solar cell is a parameter which is defined by the traction of incident power converted into electricity. A solar cell has a voltage dependent efficiency curve, temperature coefficients, and allowable shadow engines. Materials. Solar cells are typically named after the semiconducting material they are made of. These materials must have certain characteristics in order to absorb sunlight. Some cells are designed to handle sunlight that reaches the its surface, while others are optimized for use in space. Solar cells can be made of a single layer of light absorbing material or use multiple physical configurations to take advantage of various absorption and charge separation mechanisms. Manufactured solar cells share some of the same processing and manufacturing techniques as other semiconductor devices. However, the strict requirements for set requirements for cleanliness and quality control of semiconductor fabrication are more relaxed for solar cells, lowering costs. A full area metal a full area metal contact is made on the back surface and a grid-like metal contact made up of fine fingers. Different types of manufacturing and recycling partly determine how effective it is in decreasing emissions and having a positive environmental effect. The differences and effectiveness could be qualified for production of the most optimal types of products for different purposes in different regions across time. Thank you. This is my presentation.